Welcome back to the lecture series on heat transfer operation. This is Yogesh Landge. In this video, we will see the numerical which is based on the condensation of steam on horizontal tube. So let's see the numerical based on the condensation. The statement: a dry steam at 373 Kelvin on the outside surface of horizontal pipe of 25 mm outer diameter, the pipe surface maintained at 357 Kelvin by circulating the water through it. Determine the mean average heat transfer coefficient, heat transfer per unit length of a pipe. The properties of the condensate at the film temperature of 350 Kelvin are: density 974 kg per meter cube, lambda 225 kilojoule per kg, mu 306 into 10 to the power minus 6 Newton second per meter square. The K is conductivity of a fluid which is 0.66 watt per meter Kelvin. So here in this numerical it is mentioned that the dry steam is at 373 Kelvin and it is contact with the outside surface of the horizontal pipe, and the position of the pipe is horizontal with the 25 mm is the diameter of this pipe, outer diameter, and the surface temperature of a pipe is maintained at 357 Kelvin. Okay, the temperature of the steam is 373, temperature of the surface it is 357 Kelvin, and here we need to determine the average heat transfer coefficient, the value of EH. Okay, and also we need to calculate what is the heat transfer per unit length of a pipe, what will be the rate of heat transfer per unit length, and the properties are mentioned. These are the properties of a fluid of the condensate. So let's see first, as it is a position is horizontal, so we use the formula for a horizontal pipe on which the condensation takes place, and as it is a single pipe, so there is no need to go for the other equation. So let's see which equation that we need to use here. So the first one, let's see the given data. First we will write all the given data, and yes, there is one conversion is needed because the lambda value, latent heat of condensation, is given in kilojoule. We need to convert kilojoule into the joule by multiplication of the 10 raised to the power 3, that is the 1000, so that we will get the term in joule per kg. Okay, the identical unit is very important. So viscosity Newton per second meter square, which is again we convert into kg per meter second, but as it is the both the values are same, so we will write as it is. The conductivity of the condensate is mentioned. Diameter is given in mm. We need to convert into the meter because all the identical and the SI unit that we are using here for the calculations. The temperature T suffix S is represent temperature of the surface, that is the temperature of the pipe surface, and the T saturation is the temperature of a saturated vapor, which is 373 Kelvin. So this is the formula that we use, as it is a horizontal one as mentioned in the numerical. So H horizontal is equals to the 0.725 in bracket K into rho into G into lambda. K, conductivity of a liquid, that is a condensate, density of the condensate, acceleration due to gravity, and the latent heat of condensation, and all these values are mentioned. Also upon viscosity of the condensate into the diameter of the pipe, that is the outer diameter of the pipe, because on the outer diameter the condensation takes place, and the saturation temperature minus surface temperature. So just by putting the values, the value of K, put it here, value of rho, put it here, value of G is 9.81, that is a constant term, lambda, take this 2225 into 10 to the power 3 here, then the viscosity as it is mentioned 306 into 10 to the power minus 6, the diameter it is 0.025, and the temperatures 373 minus 357. So once we put it all these values, we got the answer is about around 10.76 into 10 to the power 3, and the unit is watt per meter square per Kelvin. Okay, so this is the value of pH. But in our numerical they ask what is the average heat transfer coefficient. Okay, this is the value, this is the first answer. What is the next question? The next question is what will be the value of heat transfer rate per unit length, and for that one we use the basic equation to calculate it. So to determine the heat transfer per unit length of a pipe, we have this simple equation. The Q is equal to HA delta T. Delta T is what? T saturate minus Ts. So the value of H is already we calculated. Okay, the surface area is pi dl. Okay, so what we do, we just put it the value put it the equation of pi dl here. Okay, and we just do the arrangement so that it is we get in terms of Q heat transfer rate per unit length. So value of pH is already we calculate. Pi is the constant, d value known to us, and temperature also known to us, and by putting these values we will get this answer. The Q is equals to the 13529 into 7.74 watt per meter. So this is the answer that we have. Okay, so by this way we can easily calculate the value of Q and the H. Thank you very much for watching this video. Thank you.